My name is Avinash and today I'm going to present my project on geospatial analysis of building types and their accessibility to bus stops using K-means clustering. This project focuses on understanding how residential buildings in Kansas City aligns with public transportation network and aims to contribute to more sustainable urban planning. This project is for the class CIS606 Applied Data Mining Analysis of Big Data. This project is important because it focuses on aligning residential infrastructure with public transportation. The main goal is to identify clusters of buildings based on their proximity to bus stops. This will provide valuable insights for urban planning and policymakers to make data-driven decisions that promote sustainable urban development. To process this data, I used several Python libraries. I used pandas for data cleaning and merging, label encoder to transform categorical features, and standard scaler for feature scaling. The cleaning and merging steps were critical to prepare the data for analysis, and as part of that, I created two new variables, near bus stop and distance to bus stop in miles, to enrich the data set for clustering. These two new variables, nearest bus stop was the bus stop assigned to each and every single house. Distance to bus stop in miles was value assigned to that particular housing. The main research question is, how do different building types cluster based on their proximity to bus stops? To answer this question, I use three key variables: building type, distance to the nearest bus stop, and the number of dwelling units. These variables are important because they help us understand the relationship between building characteristics and public transit accessibility, which can ultimately guide urban planning decisions. About distributed computing consideration, for my project the dataset size was small enough to handle on my local machine since it had fewer than 200,000 records. However, for large-scale analysis, distributed computing solutions such as Apache Spark could be used to process, manipulate, and analyze bigger datasets. The scalability consideration is important for future extensions of this work. For the analysis, I used K-means clustering, which is an unsupervised learning technique used to segment data into clusters. Using the elbow method, I identified that 3 clusters would be the optimal number for this dataset. This allows me to group the buildings into distinct categories based on their characteristics. Here is the elbow graph that helps me determine the optimal number of clusters. The elbow method is a critical technique used in K-means clustering to determine the optimal number of clusters for the dataset. This graph plots the sum of squared errors, SSE, against the number of clusters. As you can see, there is a sharp decrease in SSE until we reach 3 clusters, after which the rate of decrease levels off. This point of inflection commonly refers to as the elbow, indicating that 3 is the optimal number of clusters for our data. By choosing 3 clusters, we balance between model complexity and the variance explained by the clusters, avoiding both underfitting and overfitting. Cluster summary: the analysis identified 3 clusters. Cluster 0 mostly consists of houses with moderate access to bus stops. Cluster 1 consisted of homes that are relatively far from bus stops, and Cluster 2 had mostly houses that are closer to the bus stop. These findings provide more important insights into how accessible public transport is for different residential areas. Here is the summary table presents the cluster details. The table presents a summary of the key characteristics of each of the clusters. We see the mean and median values of building types, the count of buildings, and the average distance to the nearest bus stop. Cluster 1 stands out, needing better transit service coverage due to its high average distance to bus stops. If you can see Cluster 1, if you can see the average, it is around 4 miles. I also created a visualization that helps understand the cluster better. This slide shows a 3D scatter plot representing the clusters based on building types, distance to the bus stops, and number of dwelling units. So I want to show you guys the 3D scatter plot for K-means clustering for buildings I built using Python. I want you guys to focus on the building type encoder and the distance from the bus stop. The cluster 1 in red, this is the cluster which is highly affected because these are the housings that don't have proper public transportation. So if you can see this axis, the distance to bus, and the most affected housing is building type encoder 7. On this axis, 7 is single family housing. You can also see on the cluster that it says cluster 1, building type 7. Distance in miles can also be seen. It is evident that cluster 1, especially the housing with single families, need more concentration for better connectivity. Additionally, I created an interactive geospatial map using Folium, a Python library to show how buildings are spatially related to the bus stops. This visualization makes it easy to see the relationship and patterns in the data. So I'm going to show you the HTML interactive map I created for this. These are all the housing types I had, the other data set which had bus stops. So if I zoom out, this is the whole of Kansas City. A layer here has bus stop data. These are all the bus stops within Kansas City. For example, if this cluster, if you can see the heat map here, just click this, and if you zoom in inside, these are all the buses. Now I'll show you how the housing and the connectivity for the bus stop works with this mapping system. Let me pick townhouses to show you guys how it works. So when I click townhouses, you can see all these heat maps popping up. So let me click this particular heat map. Every house has its own labeling which says nearest bus stop and distance from the bus stop. There's another layer that I added to this. Is if I click the layers and the line for those townhouses map actually maps the nearest bus stop to these houses. This is the bus stop for this house and this is the bus stop for the other houses. So going back to our cluster 1. So cluster 1, if you guys remember, it was all single family houses. Select single family house. See, these are all the housing which have single family, the lines connectivity on the map. If I zoom into this part of the city where there are 3000 units. So if you can see all these houses, 3080, all these heat map, all these houses are connecting to a bus stop here. So this is definitely an area that needs more concentration. Adding a couple of bus stops in this particular route will help all this housing community to connect much better. In short, this map layer helps us understand that these are the points which need better connectivity. Just showing you a patch where this house has a good connectivity, just 1.3 miles from this particular bus stop. That is how this geospatial map works. I'm sure this will help in finding much more patterns using all the other building types. So based on the clustering results, I found disparities in public transit access between different types of residential buildings. Single families houses tend to have less access to bus stops compared to multifamily units. The findings also suggest that cluster 1 would benefit from additional bus stops to improve access. Therefore, I recommend increase in bus stops in underserved areas and promote transit-oriented developments, especially in cluster 1 area. To conclude, the clustering analysis reveals significant disparities in bus stop accessibility between different building types. This information can be used to target infrastructure improvement to ensure better access to public transit. In the future, this work could be scaled using distributed computing to include more data from multiple cities. The insights gathered from this analysis could directly inform urban planning and decision making. These are the references I used. You can find the data link to the bus stops in this link and data for the buildings data from this link. These are all the other references I used. Thank you, class and professor. I hope you found this presentation insightful. I'm looking forward for your PR responses. Have a great day. All the best.